There are a variety of organisms that can be found in streams and rivers. Oftentimes, diversity in waterways is largely impacted by abiotic factors. Global warming and increased nutrient flow are two main factors that have the potential to drastically change the ecosystems of streams and rivers. Warmer temperatures and excessive nutrients, such as phosphates and nitrates, often cause large algal blooms in waters. It may also cause the growth of something often referred to as blue-green algae. These organisms are not actually algae and are in fact cyanobacteria. Excessive cyanobacteria may harm the surrounding ecosystem, and in the case of Microcystis aeruginosa, it can pollute drinking water and be harmful to other organisms, which poses threats on food webs and biodiversity.
We wanted to test physiological tolerances and nutritional requirements to help us better understand if global warming and nutrient-rich runoff would create more suitable habitats for Microcystis aeruginosa to thrive in. To do this, we decided to test the growth of a lab strain of Microcystis aeruginosa in various solutions containing potassium nitrate percentages of 0, 0.5, 1.5, 2.5, and 3.5%. We also tested the cyanobacteria at various temperatures, such as 22, 30, and 37 degrees Celsius, using water baths set to the appropriate temperatures. The tubes of cyanobacteria stayed under white fluorescent lights for continuous cycles of 12-hour light periods, alternating with 12-hour dark periods. Their absorbance was measured in a spectrometer set at a wavelength of 600 nanometers and recorded every 8 hours for about 1 week. Growth curves were created for Microcystis aeruginosa and its various conditions, and the growth rate was calculated.
We had expected to see the greatest level of growth at 30 degrees Celsius and with the highest concentration of nitrate. We saw that there was a greater growth rate in 30 degrees water bath, but we saw the opposite of what we expected with the nitrate levels. Instead, the cyanobacteria grew better with less potassium nitrates. It turns out that the problem was the source of the nitrate was potassium salt. The potassium nitrate we added to increase the nitrate concentration actually inhibited the cyanobacterial growth. Aeruginosa responds poorly to the potassium salt form of nitrate, and so our control had the highest growth level containing 0% of this KNO3. As a freshwater organism, Microcystis aeruginosa has a fairly low tolerance for potassium. Many scientists believe that cyanobacteria tolerance or intolerance of potassium correlates with their salt tolerance, since potassium plays a vital role in maintaining water pressure in cells. More research should be done on various nitrogen forms and the effects that they may have on various cyanobacteria, especially Aeruginosa due to its toxicity.